Hello everyone, welcome back to my channel. Today we'll discuss command line argument using argc and argv. Now forgive me, I made some changes to the repo while you were absent. I changed the days to lecture, so now we have day 1 or lecture 1 instead of day 1 and lecture 2 instead of day 2. So now let's go on to learn about command line arguments in C language. I'll create a new folder for today, lecture 5. Now I'll create a test file for now because we're trying to learn, but later we're going to complete the command line calculator that we designed inside of lecture 4. So now let's just go on to create a test.c file to learn about argument counts and argument vectors. So now pound include instead, so forgive me for that. Pound include stdio.h int main void. Now this is the initial way we design our main functions, but now that is when we are not taking input into our main function, but now we want some input, we want some arguments to our main function from the command line. So now that means this would simply not work. Now the way we collect command line arguments into our main function using C language is we use int argc and then char argv. So what this does is this contains the arguments count, right, which is the total number of arguments that is passed into your command called your terminal when you run this command /test or whatever your file name is. Then all of this will be stored. So the number of these values will be stored inside of argc, which is the arguments count, and then the list of all these values will be stored inside char argv. So that's how this works. So now let's see if this theory works properly. Now let's printf no, let's print percent, or let's say argc percent I and argc. So now this, if it works properly, should print out the total number of arguments that we passed in when we run the code. So now let's compile gcc test.c output file test. So now test.c, why is this? Okay, so now let me run /test. Now we can see we have only one, argc equals 1. Forgive me for that, let me print a new line right after this. Now here we can see, let me recompile. Now we can see argc equals 1 because we only passed one value, which is the name actually of the code, our compiled file. Now let's see if we run /test arg1, arg2, third, fourth. Now you can see now that we have argc equals 5 because we passed in 5 values, 1, 2, 3, 4, and 5. But now let's see how we can print through all of the values that were provided in the arguments. Now to do that, we're going to use the argv variable. So now let's use a for loop for that. Now let's say for initialize our iterator int I, and now we can see, so this loops through the entire list of values int I equals 0, I less than argc, which means we want to loop until the end of the list, like the total number of the list. So remember, this contains the total number of values that are inside of our argument list, which is argv. Now what this does is we print the argument and then the index that we are trying to access. So we index the list and print out the string. So now let me recompile my code and let me run the same one actually I used there. So now here we can see we have argc equals 5, but then argv of index 0, which means the first value of argv is /test. That's like how it's designed. Now we have this value 2, which is index 1, contains arg1, which is the one I provided here. Now this index 2, arg2, index 3, third, index 4, and fourth. So that works properly. So now let's see how we can use this to improve the code that we wrote from lecture 4. So there would implement our command line calculator using command line arguments. So you don't have to ask for user inputs. You just run your calculator and then provide your inputs via the command line arguments. So now let me go ahead and copy all my files from lecture 4-r. So now we have all of our files from lecture 4 in our lecture 5 folder. So let me go ahead and edit our main function. Now remember I said we can't have this to work with arguments count and argument vector, so we change this to int argc char star argv. So now instead of asking for user inputs, we just initialize our variables since we already have it. But now just before we do that, let me go ahead and delete some of this, or just comment them out of our code. So now I've isolated this part of the code. It's now all comments for now. So these are ways you could just do things, like when you're trying to test things in your code and you want some part of the code to not work. So now we want to check first if our argument is a specific number. For now, let's say we want just 2 numbers inside of our argument. So now we can see argc does not equal 2. We should print and return. So printf usage /alc and then 7 or 9. So now \n so let's say return. So now this is what is going on in this code right now. We initialized 2 variables, but then we collected arguments also for the command line arguments. But now we are checking if the total number of arguments does not equals to 2, then we don't want to move on with the code. We want to like return and tell the user that okay, we provided the wrong number of arguments. But now this is where we're getting it wrong. As the total number of arguments would always, like, since it's a length of the list, we would have 2 by running this. So this ./test and hello would equal 2. But this is not what we want. We want to provide 2 values, right? 2 values apart from the name of the file. So we want 2 numbers, something like this, to add our variable. So now instead of using 2 there, would you stay instead? Now let me recompile my code and see what happens when I try to use this wrongly. So remember we have to use star.c for now, and then -o, let's say calc now. So now let me run /calc. Now you can see it's telling us usage because we didn't use it properly. But now let's go ahead and use 9 and 0. So now this works. It didn't print anything because we didn't ask it to, but then it didn't return an error either. So now we can see that it's like really checks for the usage and then responds to the user as required. So now you can see here again it's telling me you are not using this properly. But now let's go on. If the user provides the correct number of values, let's see how we can work with the code. But now just before we do that, when you provide arguments using the command line argument argv, the values will be stored using strings like char star. That is why you remember when we printed in our test.c file, we said %s for the placeholder because it contains a string. Even if you provide a number, it will still be stored inside of a string. So just before you begin to use them as numbers, you need to convert them back to numbers. So now just before we do that, I would say number equals argv and 1. So let's see what happens when we do this. So let me recompile my code, and now you can see we're having an error. So now you can see in main function line 16 we're having a warning, assignment to int from a char. So that means here we are trying to like provide a string into an integer. So as you can see there now, even if we provided a number, it will still be like providing a string for us instead of the number that we actually provided, because that's how it was designed. So now we have to convert it back to a number that is usable. So now just before to do that, we use the argc function, but it's not currently available in the default std library. So now argc, so this changes strings or characters to numbers. So that's how it's like designed. But now when we try to compile, also we'll be receiving an error, implicit declaration of argv function. So now this just says that this function is not available in the default std library that we imported in our main function. Remember we have stdio.h, like it's not inside of this header file, so we need to import another header file or include a different header file for that. Now the header file that is responsible for that is the stdlib.h, so it contains that specific function. So you need to know which functions are in which libraries to know how to use them, in which header files, so to say. Now let's go back and recompile our code and see now that it works. So now because we've gotten a proper header file for the functions we are trying to use, now we have no errors. So now when we run /calc, you can see we're having usage blah blah blah. So this segmentation fault is it's caused by the fact that we're trying to access some parts of variables in memory that we have not actually created. Now you can see in this part of the code that I said if argc does not equal 3. So now here we didn't provide any argument. So now that means this list is empty. But then we are trying to access a value in that list. So that means it's like telling us that okay, you have an empty list, but yet you are trying to access some variable in the memory of your computer that is not actually existing. So that's what causes the segmentation fault. You are trying to access some parts of your computer memory, some parts of the variable that it's actually not there. You are going beyond what you have created. So because this list is empty, but yet you are trying to like get data from that list. So that's what is causing that error. So now when I run 8, and you can see now we have no errors and no fault, no segmentation fault. So now let's go ahead and change our code to work properly. So now instead of actually having this return here, because we want it to return right after, we want to return here, return 0 instead. So now right after it's print, it will not continue with the code to even get to the point of like returning segmentation fault, because it will never get there. So now let me run /calc. So now you can see we are actually returning. So it's not running the rest of this code because we've returned from this line. And remember, this is an if condition, so it will only return if that condition is true. So you don't need to worry about the rest. Now if I should go on and run this, it will still work fine, because it only returns when this statement that is here is true. So now let's go on to add some new lines and make things work. So now number 2 equals blah blah blah. Now let's go ahead and remove some parts of the commented part of our code here. Remember, we've initialized our variables, so we don't need all of this anymore. Now we can go on and see if this works properly. So now let's recompile our code. Remember, this is what we wrote from the last video. If you didn't watch that, I would strongly recommend you go back to it and understand how this is really working. So we have several functions in several files. We have the divide function, we have the input function that we are currently not using right now, and then the multiply and subtract function. So all this work, and we have the prototypes for this function inside of our header file. So all we have to do to work with it is import our header file inside of this main file. So now you can also go back to the previous video to understand how all that works. So now let me go ahead and recompile my code here, and no errors. So let's run /calc. Now you can see we're having usage error. Now let's go ahead and use it properly. So now 9 and 8. So now you can see it's working properly because we have 9 plus 8 is 17. 9 minus 8 is 1, 9 times 8 is 72, and then division is also there. So now we've been able to provide arguments from our terminal command line arguments. Now you can see it's working like indeed properly, because we've converted the numbers to the strings that are storing the numbers to actual integers back. Then we've been using them in the calculations. But then we want to be able to do things more than this. We don't really want to like add numbers or divide numbers and have everything like displaying your screen for you. You want to be able to choose which values you are using, like you want to add this time or you want to subtract. So we're going to change this to something like this. So you run ./calc, then you actually provide your expression like 8 plus 2, whatever it is, 8 minus 2. And let's go ahead and see how we can do that. So instead of having all of this, we want to remove all of this. We have the two numbers, but then since we'll be providing our argument in this syntax, it means this second number will actually be in index 3 and not 2. So we can just move this back to 3. So now we want this because we are going to be needing 4 inputs, 4 arguments now. So we change this to 4, and then we go ahead and say, okay, if argv of 2, which is this value, like if it's equals to plus, they want to plus. If it's equals to minus, they want to subtract. If it's equals to divide, you want to divide, and if it's equals to multiply, you want to multiply. So we're going to use the if conditions to determine that and then carry out the proper arithmetic operation inside of our code. So now if it's equals a single string, so now we can see we have all of this available now. So we have if it equals plus, if argc of 2, which is the sign, equals plus, we have which print out the addition of those two numbers. Then if it is this, we want to print out the subtraction. And let's go ahead and see how this works. So let me go ahead and recompile my code. We have several errors. So now here we can see we are having comparison between a pointer and an integer. So this is like not working because we are having the list as actually a pointer, not an integer. So just before we go ahead and do that, we can instead create a variable that is called let's say char and operator here. So then we go ahead and like store the operator inside of the variable instead. So just before we do this, no. So now let's go ahead and change all of this argc to operator instead. So now let me recompile my code and see what happens. Still we have an error. Why is that? We're trying to assign from char to char star without a pointer cast. So let's say 0 and see how that works. So now we can see that works properly. So now the reason why that wasn't working was we have argv, which is a list of the arguments, but then it's not exactly a list, it's a pointer. Something you don't really have to understand right now. We'll be discussing that later. So it's like a chain of values inside of the memory, so it points to each other. So then we cannot really initialize a pointer into a character without like having something like this. So for now, just leave that and let's move on to the rest of the code for a bit. In the next videos, we'll be discussing about pointers and all of that. So now let's go ahead and I've recompiled my code now. Let me run ./calc and this. So this works fine because we added 882 and 18 and that works properly. So let's say minus instead. Now that worked fine also. Let's say divide. Remember for the divide we are using the slash, so we have that also. Division and then multiplication, we use the star for that. But then we have an error for that. Why is it? It's not recognizing the star operator for some reasons or the other. Let's try to find out why that is. Okay, So this star argument, right? Remember, in the command line terminal we can use this star operator also as a wildcard operator. Now remember when I used this copy function earlier, where I used cp-r and I say dot /lecture, and I use this star. So this star is a wildcard operator. So now when we are running it in our command line, it's trying to do something else apart from really running to our code. So the command line argument is actually not capturing that variable because it's a wildcard operator. You have to escape it. So then we don't have to worry about that right now. So to just use it, you need to use the single or double quotes to escape and make sure it works. So the only reason why this is happening is because our terminal is trying to like read this into a different meaning. So just do this and it still works fine. So let's make this let's make this look a little better by saying we have two more values here instead. Let's say number and number 1. Operator and number 2. Yeah. So let me go ahead and copy this and paste it for the rest of the print functions. So now we want to like print out the expressions in full, not just the answers to the expressions. So now here would say %d %c. Remember, we're having a decimal number or a string, a decimal number, then a character, then another decimal number before that. So let's say %d also. Okay, so that is that. Let me go ahead and copy this for the rest of the code. So let's say we have this here also. No. So now when I recompile my code and then I run this, we would have 8 times whatever it is and then the values. So now I forgot about the equals value here. So equals and then equals also. So let me recompile my code. Run /. So now we successfully have a command line calculator that takes command line arguments to like make calculations for us. So now let's say /clc 7 minus 2. That works fine also. So let's say 7 divided by 2, and then for the times, always remember you have to use the single quotes to escape the wildcard operator. So this works fine. Now let's move on and learn some other variables, some other functions in C language in the next video. Thank you for watching. Please like the video and subscribe to my channel for more contents. Goodbye.